This video is to help you with the computer project associated with Unit 11 on using a z-test of significance to test a coin for fairness. I will use an open office spreadsheet this time, so the symbol separating the arguments of a function is a semicolon. And as usual, I will change numbers, so you should get different results. For both a fair and an unfair coin, I will ask the spreadsheet to compute 30 repetitions of the following test. Flip a coin 400 times, count the number of heads, and then decide whether that count is within the specified interval for the coin to be called fair. For the fair coin, I will use an alpha level of 8%. That is, I will declare the coin unfair if its count is so far from the expected count of 200 heads that it would only be that far off, or further, 8% of the time. With the unfair coin, I will use an alpha level of 15%. The usual alpha level is 5%, of course. I'll record my results on the first sheet of the spreadsheet so that I can compare them easily and do the computations on other sheets. We'll need to figure out what intervals in the counts correspond to the chosen alpha levels. For that, I don't need the spreadsheet, I need a normal table. Because I'm doing two-way tests, for the 8% level, I need to find the z-value for which 100 minus 8, or 92% of the area, is between minus z and z. The normal table says that is z equals 1.75, so I convert that z value into counts, 182.5 and 217.5. They're fractional, of course, but that just means there won't be counts right on the dividing line, so it's a good thing. Similarly, at the 15% level, the cutoff counts are 185.5 and 214.5. Now I'll actually want to simulate flipping coins. For a fair coin, on the second sheet, the command is equals if, open paren, rand, open paren, close paren, is less than 0.5, semicolon 1, semicolon 0, close paren. I drag that down to cell A400. Then in cell A401, I can put the counts of heads, equals sum, open paren, A1 colon A400, close paren. I can highlight that whole column, A1 through A401, and drag it across to the 30th column, AD. In column AE, I use the cutoff counts that I found earlier for an alpha level of 8% to make a bin range. And then I use the frequency command to find out how often, out of the 30 trials, the count of heads was significantly too low or too high, from which we would conclude that the coin was unfair. Equals frequency, open paren, A401 colon AD 401, semicolon AE1 colon AE2, close paren, with Control-Shift-Enter, of course. It turns out in this case that the coin was never too low, but twice it was too high. The test should only make that mistake 8% of the time, but 8% of 30 is 2.4, so it's not surprising that it made two mistakes. I want to copy those results to the first sheet. The natural thing to do is to highlight the cells we want to copy and hold down the Control key as I hit C for copy. Then I would click on the tab for the first sheet, highlight the upper left cell of where I want those figures to go, and, well, normally I would just hit Control V, which I think of as put whatever is copied to the clipboard down here. But it turns out that because I've switched sheets, that doesn't work. I have to go to the Edit tab and choose Paste Special, which gives me a menu on which I want to unclick Formulas and click Text. Then clicking OK gives me what I wanted. On the third sheet, I simulate flipping an unfair coin. Equals if, open paren, rand, open paren, close paren, is less than 0.6, semicolon 1, semicolon 0, close paren. Then we proceed as we did with the fair coin. Notice that because one coin was fair and the other unfair, the significance test can be wrong in two different ways. For the fair coin, the test is wrong in the two cases out of the 30 where it found a value outside the cutoff interval. For the unfair coin, the test is wrong in the one case where it found a value inside the cutoff interval. A type 1 error is where the null hypothesis is right but rejected anyway. For example, a fair coin is called unfair. A type 2 error is where the null hypothesis is wrong but not rejected. For example, an unfair coin is called fair. With a little thought, we can see that the alpha level is exactly the probability of making a type 1 error. If we can find the probability of not making a type 2 error, that is called the power of the test. In this case, we might actually be able to find the power because we know exactly how far from fair our coin really is. We built the coin's unfairness. But in most cases, we don't know whether the null hypothesis is wrong, much less how wrong it is. So we have no way of computing the power of the test.